Understanding space boundary.
Kármán Line and the atmosphere layers.
Where does Earth end and space begin? The Kármán Line draws the line at 100 kilometers up. Fly straight up and watch the sky darken as you near space's doorstep. Earth's end isn't a hard line, but a gradual fade into the cosmos. Earth's atmosphere is a complex system composed of several distinct layers, each with its own characteristics and functions. The troposphere is the lowest layer, extending up to about 8 to 15 kilometers above the Earth's surface. This is where we live and where weather phenomena occur, as it contains the majority of the atmosphere's mass. Above the troposphere lies the stratosphere, reaching up to about 50 kilometers. This layer is home to the ozone layer, which absorbs and scatters the sun's harmful ultraviolet radiation. Next comes the mesosphere, extending from 50 to about 85 kilometers above the Earth. It's known for being the layer where most meteors burn up upon entering the atmosphere. Finally, the thermosphere stretches from 85 kilometers to as high as 600 kilometers. This layer is characterized by increasing temperatures with altitude and is where the auroras occur.
As you ascend through these layers, the atmosphere becomes progressively thinner, meaning there are fewer air molecules at higher altitudes, which affects temperature, pressure, and oxygen availability. The Kármán Line is generally recognized as the boundary between Earth's atmosphere and outer space. It is located at an altitude of 100 kilometers, about 62 miles, above sea level. Named after the Hungarian-American engineer and physicist Theodore von Kármán, this line represents the point at which the atmosphere becomes too thin to support aeronautical flight, as the required speed for an aircraft to generate lift would be equivalent to orbital velocity. This boundary is used by various aerospace and international organizations to differentiate between airspace and outer space. Space is often thought of as a vast empty void, but in reality, it is not completely devoid of matter. The Earth's atmosphere gradually thins out as you move away from the surface, extending well beyond what we typically consider the boundary of space. This gradual thinning means that even hundreds of kilometers above Earth, where satellites orbit, there are still traces of atmospheric particles. These particles, although sparse, create a phenomenon known as atmospheric drag, which can affect the velocity and orbit of satellites over time. This drag is a result of collisions with these residual atmospheric particles, which, despite being few and far between, can still exert a small force on the satellites, necessitating occasional adjustments to maintain their intended orbits. Therefore, while space may seem empty, it is more accurately described as a near vacuum with just enough particles to have a noticeable impact on objects traveling through it.